everyone, my name is Nikita and I am from the Bodhi Academy. Today we are going to start with a new chapter from 10th Standard Science textbook, that is Light, Reflection and Refraction. Okay? So what do you understand by this term reflection? Okay? Reflection. In basic words, okay, in common words, we can say that the reflection is the bouncing back of light. When light falls on the shiny surface, it bounces back, okay, and that's the way an image is formed. So reflection of light is nothing but it is the bouncing back of light. When we talk about reflection, we always talk about the mirrors, and we have two kinds of mirrors, the plane mirrors and the spherical mirrors. Plane mirrors are the ones which will have a plane reflecting surface, okay, and spherical mirrors will be the one which have a curved or a spherical reflecting surface. When we study about reflection, we need to also study about the two laws of the reflection. Okay, now I have said that a ray of light bounces back. Okay, so a ray of light, first of all, it has to fall on the shiny surface, it has to fall on the mirror. The ray which falls on the mirror, this ray is called as the incident ray. Okay, and then the same ray is reflected back, then that ray becomes the reflected ray. So we have the incident ray and we have the reflected ray. Okay, so now let's study this using the help of with the help of a diagram. Okay, so consider this surface to be a plane mirror. Plane mirror. On the top part is the reflecting surface of the mirror and the bottom part is the plane surface. Okay, on the mirror there is a reference ray. Okay, a reference ray. This reference ray is called as the normal. Okay, normal ray. Now we need to study the incident ray, the falling of the incident ray and the reflecting of the reflected ray, and for this reason we need one reference. So over here our reference is the normal ray. Okay, so now when a ray of light, okay, a ray of light now is falling on the mirror. Okay, it is falling on the mirror. Okay, and it is falling this way, so the arrow is downwards, and this is called as the incident ray. As it is incident on the mirror, it is called as the incident ray. Okay, now over here when it falls on the mirror, over here the reflection of this ray of light will happen, and after the reflection it will get reflected. It will get reflected, so it will go back. Okay, and this ray now is called as the reflected ray. So we have the incident ray, the normal and the reflected ray. Okay, now we need to know that this, okay, the incident ray, okay, the incident ray is meeting the normal ray over here, so it forms an angle with the normal ray. That angle is called as theta. Okay, also the normal ray is forming an angle with the reflected ray. Okay, that is theta. This is called as the angle of incidence and this is called as the angle of reflection. Okay, so the angle formed by the incident ray and the normal ray, okay, incident ray and the normal ray is called as the angle of incidence, and the angle formed by the reflected ray and the normal is called as the angle of reflection. Okay, so we have two angles over here and two types of rays. Now what are the laws of reflection? The two laws, okay, from that there are two laws of reflection. From the first one it says that, okay, it says that the angle of incidence is equal to the angle of reflection. Okay, so the angle of incidence is equal to the angle of reflection. Okay, this is the first law. The angle of incidence is equals to the angle of reflection. Now the second law. What are the second law states? Second law states that all these three, okay, the incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. Okay, incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. So this is the second law of reflection. Lie in the same plane. Okay, so these are the two laws of reflection, and these are important as all the reflection part is based on these two laws. Okay, the incident ray and the reflected ray. So this was about the plane mirror. Okay, the plane mirror. Now we are going to see something called as the spherical mirrors. Okay, we are going to see the spherical mirrors. Now what are the spherical mirrors? Spherical mirrors are the mirrors which have a curved or a spherical reflecting surface. Okay, for example, consider the sphere. Okay, sphere which has a center. Okay, spherical mirrors are taken from the part of the sphere. Okay, so spherical mirrors are basically the part of the spheres. They are cut from the sphere. Okay, so when you take it from the sphere, you have two kinds of mirrors. Okay, there are two kinds of mirrors. The one with the reflecting surface, okay, the one with the reflecting surface which is curved inwards, okay, reflecting surface curved inwards is called as the concave mirror. Concave mirror. And the one with the reflecting surface curved outwards, okay, that is called as the convex mirror. Convex mirror. So over here you can see that the reflecting surface, this represents the reflecting surface, the outer part which has these lines, it represents the plane surface. So concave, cave means inside. Okay, so the reflecting mirror which has a spherical, the reflecting surface is curved inwards like a cave, it is called as a concave mirror, and the one which has a reflecting surface curved outwards, okay, outside, it is called as the convex mirror. Okay, so these are the two kinds of mirrors which are called as spherical mirrors. So we have two kinds, the concave mirrors and the convex mirrors. So now let's see the different measurements and which are present in this. Now I had mentioned that these mirrors are taken from the sphere. Okay, so sphere has a center. So that center, this center applies to the mirror also. When you take the mirror, no, even after you are separating the mirror from that sphere, that center remains the same. Okay, we consider the sphere's center to be the mirror's center now, and that is called a center of curvature. Okay, so now we need to learn some measurements. Okay, so I will draw the, so which mirror is this? The reflecting surface is curved inwards, so this becomes the concave mirror. So let's see now. Okay, so now the center of this mirror, okay, center of this mirror is called as pole. It is given by letter P. Okay, so the center of this mirror is called as pole. Okay, P for pole. Then there is a straight imaginary line which passes through the pole. Okay, a straight imaginary line passing through the pole. It is called as the principal axis. That is called as the principal axis. Now, here I had said that the center of the sphere, okay, this is the center of the mirror, okay, and this is the center of the sphere. So now when we consider the center of the sphere, we write the center of the sphere exactly in the center, okay, so over here. So this center is represented by letter C, and it is called as center of curvature. Okay, now exactly at the midpoint of this two distance, okay, midpoint of this distance between these two, there lies the principal focus. So F is given by principal focus. So we have three measurements. One is the pole, then is the center of curvature, and then is the principal focus. Now let's talk about the length. Okay, what are those lengths called? Okay. Now, so the distance between C and P. Okay, this distance C and P, CP, this is called as the radius of curvature. Radius of curvature. Okay, the distance between the center of the curvature C and the P pole is called as the radius of curvature. Okay, now the distance between the focus, principal focus, and the pole, okay, that is PF, okay, or FP, it is called as the focal length. Focal length. Okay, so we have, first of all, we have the pole, which is the center of the mirror. Then we have the center of the sphere, which is called as the center of curvature C. Then we have the principal focus, which is F, and we have the imaginary line passing through all of these, okay, which is called as the principal axis. Okay, the distance between the center of curvature and the pole is called as the radius of curvature, and distance between the principal focus and the pole is called as the focal length. Now I had mentioned that the principal focus lies midway between these two. It lies exactly in between these two, means exactly in the middle. Okay, so you can deduce a formula. Okay, now first of all, the radius of curvature, no, it is given by the capital letter R, and focal length is given by the small letter F. Okay, principal focus is given by the capital letter F, and focal length is given by small letter F, and radius of curvature is given by a capital letter R. Center of curvature is given by the capital letter C. So we know that the focus lies midpoint, the center, the radius of curvature, it lies in the middle. Okay, so from here we can say that the radius of curvature, this full distance is twice the focal length. Okay, we know that this is the focal length, right? This is the focal length and this is the radius of curvature. So we can say that the radius of curvature, okay, the radius of curvature, which is R, okay, the radius of curvature is equals to 2 times the focal length. Correct? No? Because see, over here it is F and F. F plus F is 2F, which gives you entire R. So radius of curvature equals to twice the focal length. So this can also be written as F equals to R by 2. Means if the focal length is 8 centimeter, then R will be 8 times 2. It is a 16 centimeter. Okay. So this is one first formula from this chapter which we need to study. Okay. So we have seen what is the plane mirror, what are spherical mirrors, and different measurements of spherical mirrors, and the formula of the radius of curvature and the focal length. Okay, so the formula which connects the radius of curvature and focal length is R equals to 2F. Okay, so in the next video we will be studying the principal focus of concave and convex mirror. Okay, so thank you for watching my video. Please like, share and subscribe to our channel.